Good afternoon, good morning, everyone. Welcome to Smart Buildings and Convergence, sponsored by CTS and Corning. And we're going to start the webinar in about 1 minute to let everybody load in. So we'll be back. We will hear silence for about another minute, and then we will start. Okay, I think we're going to start now.
Okay.
Welcome, everyone. Welcome, everyone, to our webinar today, titled Smart Buildings and Convergence. Your sponsors are CTS and Corning. And I'm Rich Berliner from Connected Real Estate Magazine, and I will be your moderator. So welcome, everyone. Some notes before we start. We will do what we can to answer all your questions during the webinar. If not, we will answer them during the Q&A session at the end of the presentation. Please ask all your questions via the GoToWebinar control panel. We're recording and we'll publish a link to the recording within a few days, including any of your questions that get answered during the webinar. Today's slides and the article that this references in the presentation will be emailed to everyone within the next few days, along with a link to listen in on this presentation, should you want to go back and do that again. If you'd like more information about this topic, please go to www.cts1.com or connectedremag.com, and you may find additional information there. It's my privilege today to introduce our panelists. Blaine Shore, Director of Emerging Technology for CTS, Neil Medges, Sales Engineer from CTS, and Jason Green, Director of Architecture for Corning, and they will be your speakers. So today's agenda for this webinar: what is a smart building? Why fiber deep based infrastructure? Converging applications? What is software defined LAN? Advantages and benefits? Use case study, and Q&A. So without further ado, I'd like to introduce our first presenter, Neil Medges from CTS. Neil?
Thank you, Rich. Again, I'm Neil Medges with CTS, and I'm a sales engineer for our fiber-based LAN solutions offering. I want to thank everyone who's participating on the WebEx today, and give a shout out to Kate Sheehy at CTS for all of her help in getting the word out for the WebEx. Hopefully you'll find our discussions on smart buildings and convergence informative. Okay, first slide. I'd like to start with the definition of a smart building. The TIA defines a smart building as one that uses an integrated set of technology systems, infrastructure to optimize performance and occupant experience. This includes any building that uses automated processes to automatically control a building's operations, including heating, ventilation, air conditioning, lighting, security, and other systems. Today, the Internet of Things offer innovative smart building solutions to meet these goals as well. I'm going to give you some quick facts here on financials. So there's a company called Property Technologies, or PropTech, which consists of any technology geared toward the real estate industry. It saw close to $20 billion in investments last year, which was a 38% increase from 2017. That being said, commercial real estate owners and operators are focused on three key trending technologies. That's business intelligence, operational asset intelligence, and tenant experience. I know, and I'm sure a bunch of you guys know, how many times you walk into a building and the first thing you do is to see if your phone has, a carrier signal or a Wi-Fi signal. Everybody's always wanting to be connecting. And next slide. what we're finding is the present day employee is empowering mobility. Today, 52% of employees are working wirelessly, and by 2021, 69% will be going wireless. Mobility utilization is 38% today, and by 2021, it is predicted that it will be 53% will be mobile. By 2020, there'll be 30 billion connected devices. So now I'm going to pass over to Blaine. He's going to talk a little bit of why fiber deep and why convergence. So Blaine.
Hi, this is Blaine Shore with CTS, Emerging Technology Director. I want to thank everybody for joining today. But the slide says why fiber deep. I think we need to back up a little bit and kind of find out how we got here. We've had a couple decades where technology has grown. Back in the 90s, we were kind of looking at the Moore's Law, which technology doubled. And so then that would drive new cat or levels of cable. So, 3, 4, 5, 5E, 6. We're kind of today, we're at that 6A a level of cabling, but it would always drive it. And so never could actually get ahead of it. And so one of the reasons for, why fiber deep, if we had the opportunity to get ahead of technology, that'd be awesome, because then we kind of get out of the recabling mode. But, what's driving fiber deep? With streaming, cloud-based services, Wi-Fi 6, we have CBRS that's really here now and really going to take off, the private LTE, and then we have IoT, obviously. But let's look at Wi-Fi 6. Right now you've got Wi-Fi 6 that is, because of the faster speeds, greater capacity, just to name a couple, it's going to require 6A cable. Well, a lot of people that are going to want to enjoy the benefits of Wi-Fi 6 are going to have to upgrade their cable plan. I was just reading an article the other day that said that Wi-Fi 6 is going to require 6A, but really Cat 7, and that would last for a while. Well, one of the problems with that is, what's a while? Your typical life cycle of a cabling or infrastructure for your building used to be about 5 years. Well, now because of growing technology and what's coming down the pipe, that's really shrinking to about 2 to 3 years. So, if you're a builder, a REIT, a group that's building buildings today, well, you're in the design process, you're not going to really open those doors probably for a couple years. So you kind of see what the issue is with Wi-Fi 6 alone. If I design in 6A cable today, my life cycle is a couple years. Then when I open it, I may have to recable potentially. So it's a real issue to try to, get that right infrastructure put in, and one of the big reasons for why fiber deep. Verizon and AT&T came out in January stating that, they'll only guarantee fiber deep for 5G when that really comes reality in building. Fiber deployments cost less. When you look at the dynamic on the size of one fiber infrastructure versus Cat 6, Cat 6A, it's a lot smaller. It reduces my IDFs, it reduces my conduit, it reduces my cable tray, reduces my overall infrastructure, which is what we call building effect. And it really reduces the cost of your overall infrastructure costs. And then at the end of the day, your management. Then we can converge multiple systems, which you're seeing more and more of building systems going IP based. Well, now we can converge all of those over a common fiber infrastructure. Jason's going to talk about that in the case study later on in the presentation. And then finally, the limiting factor in a layered architecture is characteristics of copper cable. A lot of guys say, well, I can only go 300 feet. What if I could go 500 feet? That's why a lot of transportation or terminals today are choosing fiber to the edge technology, because my reach, I can go so much further than that 300-foot limitation of copper. And then I can only go 10 gig as the maximum I can go on a Cat 6 cable or 6A cable. Well, somebody said, well, 10 gig, that's a lot. Well, as Neil stated, when I'm 69% of the offices that are going to go Wi-Fi, 100% Wi-Fi, I have multiple 1 gig users hitting a single access point. You start understanding why it's important to have a cable that'll go faster than 10 gig potentially. Next slide, please. Again, with converged applications or converged solutions, we look at things differently. We have to look at that design differently when we look at a building. And obviously, we have to have somebody involved that's going to control multiple budgets. When Neil was talking about prop tech or property technology, the way to get the most benefit out of your investment dollars is to be able to get an infrastructure that will carry multiple applications or solutions and have 10, 15 years, 20 years of life versus that 2 to 3 years, which then optimizes your investment. We talked about multiple applications. On the right side of the screen are, some of you might know, some of you might not, but this is the master format of division, which is the design standards for infrastructure for all low voltage or infrastructure systems. And here's an example of division 25, 27, and 28. And in the master format, it shows all of the IP systems that we can converge over one fiber infrastructure. And it's pretty impressive. And I don't want to keep shoving it to Jason, but he'll really bring it to life at the end where he talks about a case study where they tied in a lot of these systems that you see there on the screen into and run across one converged network. Next slide, please.
All right, it's back to me, it's Neil again. So we're going to switch it up and discuss how we can converge all these systems and applications onto a single platform utilizing the Corning software-defined LAN. As Blaine just mentioned, the 5-year life cycle for traditional copper infrastructure is now projected at 2 to 3 years. So deploying fiber-based LAN solutions will eliminate the need to rip and replace your cabling plant as the technology life cycle continues to evolve. So it's time really for the IT managers to start designing their networks differently. So with the software-defined LAN, we're kind of decoupling the hardware and software layers and providing a centralized network platform. Using a software-defined data plane, we're able to utilize the built-in intelligence to reduce and provide for flexible topologies options to the IP devices connected to the edge. The edge device is known as the software-defined access node, and that's at the bottom of the screen. That comes in 1 port, 3 port, 4 port, and 8 port. The SD-LAN can be connected directly to a software-defined data plane or directly to an OLT. Later, Jason's going to break out, components that illustrate network connectivity designs in the case study for both point-to-point active Ethernet and point to multi-point PON applications. So next slide. Okay, so software-defined LAN, is it different or is it the same? With utilizing a fiber and power deep topology, we can centralize the control and flexibility of moves, adds, and changes without the need to replace your cabling in a traditional LAN. The end devices and applications for AV, Wi-Fi, phones, printers, all your converged applications will function the same with the standard IEEE networking protocols without all the copper cabling and traditional copper switches. I'll now pass it back to Blaine, and he's going to talk about some key advantages and benefits of the system.
Thanks, Neil.
Yep.
So when looking at the advantage and benefits, now understanding that to get these benefits, you have to have a fiber-based LAN solution. You have to have fiber throughout the facility. Just some of these that we can point out, and we help customers with this all the time, where we do comparisons, we do designs for folks to show them where those advantages are. But savings is not only in the OpEx, but also the CapEx, but the OpEx. It not only in that initial build, but it takes less management time to manage this kind of network than it does a traditional fiber copper network. Lower energy consumption. The deployments take a lot less time because you're running a lot less cable and a lot less infrastructure. Reduced pathways, and I talked about that a little bit earlier, where I don't have near the conduit, I don't have near the the cores, the IDF size, cable tray, ladder rack, all those things that go into infrastructure. And, sometimes when you're just, signing the check, so to speak, you don't see all the parts and pieces that go into one of these builds. And when you start taking out some of those pieces, it can really add up in a large facility. Ease of Mac work, Neil talked a little bit about that. Highly flexible, easy to configure and manage. We can go into a typical environment and typically takes us, just a few days to rack and stack the head in, configure the system, bring it up. And so a lot easier from a configuring and a management perspective. Next slide, please. I think one of the most important things here is the first bullet is less human touch. And you might think, well, why is that important? Well, in a traditional environment, every time I have to make a change to the network or I'm troubleshooting, I have to go to the IDF, I have to get on the access switches, and I have to make changes or do work on those switches. And that's human touch. Well, why is that important? Well, it's a big security. The CIO of the Air Force just came out and basically said that from now on, they're doing all fiber to the edge on all networks because they looked at human touch as the most important aspect of reducing the security risk. When I can reduce the amount of equipment in the environment, I reduce human touch, which then reduces my security risk. And so obviously, not only the military, but your buildings that you're building, the companies that will be in it are all concerned about security. We have SDANs that are simple management. So everything is done via central management at the head end. Greater connectivity density. That's one thing Jason will point out in the case study, that they saw a lot greater density when they went from a traditional to a fiber-based LAN, fewer moving parts. And obviously part of the work of IT and IT team is all the parts and pieces in the network. And so less time to do that. Central management. With SD-LAN, it's an enterprise platform and really easy to manage, so really reduces that operational time. One of the things that I think it's important at the bottom here is that when you compare conduit costs, well, you really don't think of that when you talk about IT. When you talk about speed and big bandwidth and low latency, and well, we don't talk about this, but obviously it's a big part of your overall budget. When you look at this one where I'm going from a 2.5-inch conduit, and actually we just saw a study where it went from 4-inch and 3-inch because it was 6A cable that it required conduit. We reduced that to 1-inch and 3/4. We saved so much on the network that it saved for the technology. It paid for the technology. So when you look at reducing conduit, and you got a picture of the ladder tray there on the side, or basket tray, it can really reduce, if you pull all those pieces together, it greatly reduces your overall cost of the network. Next slide, please.
Okay, as Blaine and I just mentioned, the reduction in copper cabling is a huge benefit, and not only in cost, but there's two distinct advantages, which is scale and reach. So the composite cabling is manufactured in various combinations of copper conductors and single mode optical fibers, all under a single hybrid cable. The cable is plenum, which is perfect for above ceiling use in offices, hospitals, be used in schools, any application, hotels. As you can see in the photo, there's a large difference in copper cable reduction, with utilizing fiber. So I'm going to try to walk you through an example. If we were to cable 4 ports of CAD 6A, the cable per linear foot is 36 cents. So if we multiply that by 4 to get 4 data connections, then we're raising our cost up to $1.44 per linear foot just to get those 4 data connections, compared to using the composite cable, which is only at 11 cents per linear foot. This allows you, with using an SDAN, and I mentioned those SDANs come, the software-defined access nodes, they come 1 port, 3 port, 4 port, and 8 port. So at 11 cents a foot, we could actually provide out to a work area outlet and put an 8-port access node out there, which is a huge savings, because you're talking $1.44 per linear foot versus 11 cents per linear foot. So There's a big savings in the material and potentially raceways, as Blaine mentioned in the previous slide. We're replacing all that copper cable and just putting in the skinny, composite fiber. We don't need the large raceways anymore. So space savings and the costs speak for itself. Jason, as we mentioned, is going to have some photos in his presentation of the Corning site. Next slide here. Okay, so to recap, the utilization of the centralized power supply units and the Actify composite cabling, we can safely provide Ethernet at a greater distance than traditional cabling with the simplicity of fiber optics deep into your building and network design. So now I'm going to pass it off to Jason Green, who's going to present the Corning case study, and he's got a little video which hopefully you guys all enjoy.
Thanks, Neil and Blaine. Appreciate it. Again, my name is Jason Green. I run the solution architecture team here at Corning. So we're responsible for assisting customers and great integrator partners like CTS in deploying smart buildings, and we do that in a fiber deep architecture, which we'll talk about. What I'm going to do is I'm going to start off with a video. Before we start the video, I'll tell you a little bit about the site. So this is the corporate headquarters building for the communications division of Corning Optical Communications. It is in Charlotte, North Carolina. It's a 6-story building, and it houses or has the capacity to house approximately 700 employees. So when we went to build this the building, we did have a goal of being a very smart building, the smartest building in the area. We do think we achieved that. So what I'm going to do is I'm going to do a quick video here. So Peter, if you could start the video, we'll do a quick fly through, and then we'll dig into some additional details. All right, thank you for that, Peter. So as you can see, it's a very open environment. We've embraced the wireless office. So if you can go ahead and progress a slide, I'll start discussing some of the network applications that we're supporting in the building. Thank you. Okay, so in the building itself, we have approximately just under 2,000 network ports that are deployed throughout the building. We're doing all of this from a single closet. Because we're leveraging a fiber topology in this building, we're not held to the 300-foot rule that you would typically have in category cable. And so we do have runs from the first floor going all the way up to the 6th floor. But we're also covering the outdoor space as well. So we do have several runs that well exceed 1,000 feet, just as an example. We're serving those network ports through software-defined access nodes, or ONTs. Both Neil and Blaine referenced those during their presentation. So these are approximately 402 of these applications that it's serving things like security cameras. We have a lot of security cameras, both within the building and also outside in the parking areas. We have a very dense Wi-Fi deployment as well, 111 Wi-Fi access points. The Wi-Fi was very important to us at Corning. So as I mentioned previously, we have fully embraced a wireless environment. Some people might think that Corning would want wires because we're a infrastructure company, but that's actually not true. We very much have embraced the wireless office. And so what I mean by that is there are no network drops at the workstations. All computers are connected via Wi-Fi at your workstations. That's also true for the voice. So because we don't have a network drop at the desk, we have our employees are either using soft phones from their PCs, which are ultimately connected to our Wi-Fi access points, or they're leveraging their cell phone, and we do have a very robust small cell system with our Spider Cloud solution deployed as well. Video distribution. So we have the 400 access nodes that we talked about, but we also have quite a few Crestron NVX, which is a 4K video distribution system. So these are in all the conference rooms throughout the building. So this is a direct fiber device. So in this case, we have one of our SFPs, which is plugged directly into the Crestron device, and that's a home run connection all the way back to the MDF closet on level 1. And those devices have quite a high throughput level, so we see about sustained throughput of about 800 meg per device as an example. Next, sound masking. So because we are a very open environment, when you walk into our building, you'll notice there's not a lot of walls. So we've embraced kind of that open architecture. Because of that, we do have noise canceling sound masking. We use a vendor called Creative Cambridge Sound, pardon me. And so that's also connected through our software-defined LAN system. So we have sound masking controllers that are throughout the building. Each one of those controllers serves approximately 8 speakers, and they're getting that network connectivity from a software-defined access node that's sitting on an open cable tray that we have throughout the building. Other applications we have from the AV side, we have quite a few scheduling panels for all of the conference rooms throughout, touch panels in the conference rooms. I spoke about our cellular solution. So we have our Spider Cloud solution is deployed for both AT&T and Verizon. So those are dedicated radio nodes that look like wireless access points. We have those throughout the building. And so we do have a very robust license frequency for both AT&T and Verizon in the building. 7 signals. This is a sensor that helps to optimize our Wi-Fi. We're using a Cisco Wi-Fi architecture in our building, but both the 7 signal devices as well as the Wi-Fi access points are both coming back into a software-defined access node. So again, all of this is feeding directly back from that MDF. And then we have kind of some of the things you would expect in an office building. Printers, we have some LAN drops in various locations. I was surprised to see that we still have some fax machines in the building. I'm not sure who's using those fax machines, but we do have 9 fax machines in the building. View glass. So view glass is a neat technology that we're supporting in the building. So this allows the outer casing of the building is all in this view glass, and it does darken or lighten depending on the day to kind of optimize both our HVAC system, but also allowing a lot of natural light within the building. We have a full cafeteria with menu boards. Obviously, we have access control. So as you can imagine, this is what you would expect to see in kind of a typical office building. And in our case, everything is fed via very fiber deep architecture. If you could progress a slide. Okay. So as you might can imagine, Corning's a Fortune 500 company. Network uptime is very critical for us. We did deploy this in a high availability architecture with a lot of redundancy built in. And so I'll quickly step you through this architecture. So we have 2 Cisco routers in the building. We have one that's in the main closet on the first floor, and then we do have a secondary closet on the 3rd floor. The purpose of that secondary closet is just to hold those redundant components. So that would be the second router as well as the second top of rack software-defined data plane. And those software-defined data planes, that's the next box down. Those are the boxes that both Neil and Blaine referenced during their presentation. What this is a SFP plus switch. So we have 48 SFP pluses. So each one of those ports can be 1 gig or 10 gigabit, depending on the application that's at the edge. And then it also has 6 QSFP plus ports, which are 40 gig. So if I want to uplink to my router with 40 gigabit or multiple 40 gigabits, I certainly can do that. And so we have in our architecture in our building, we do have 2 of these top of racks. And that, again, that's just your standard star topology for redundancy. So if we do have a failure of a router, we don't lose network connectivity. If we have a failure of a top of rack switch, we also don't lose network connectivity. Of course, both those top of racks are connected to all of the aggregation data planes throughout the facility. In our case, we have 8 additional software-defined data planes and an aggregation setup. So that's what's feeding kind of our high throughput devices throughout the building. So examples of that in our building would be Wi-Fi. So all of the, as I mentioned previously, we are a wireless office. That wireless access point is quite critical for us because all of the network data is going through that, but also all of the voice throughout the building is also going through the Wi-Fi in the case of the soft phones on our PCs. And so we do have a dedicated gigabit feeding software-defined access nodes connecting into those Wi-Fi access points. That's also true on the AV. So the AV is a very bandwidth-hungry application as well. So we have that in a point-to-point configuration as well, which is feeding those Crestron NVXs like I referenced previously. And then finally, the cellular solution. So the distributed small cells that we have throughout the building are also in a point-to-point configuration. So dedicated gigabit going to an ONT, which is then serving a radio node for both AT&T and Verizon. On the right-hand side there, you can see our point-to-multipoint technology. And again, all of this sits on the same network, and you manage this on a single pane of glass. But that white box is what we would call an optical line terminal. So that's a point-to-multipoint switch. And so the way that works is I have instead of having a 1 gigabit or 10 gigabit optic leaving, I have a 2.5 gigabit PON SFP. So that's ultimately going to hit an optical waveguide or optical splitter. And that's going to allow us to take a single fiber out of that box, but it's going to hit that optical splitter and inside a building that's typically serving up to 32 ONTs. And so the applications that we're using there, we're going to use those applications that don't make sense to have that full gigabit. So things like the scheduling panels outside the conference rooms, the touch panels for the conference rooms, the printers, the sound masking controllers, even the security cameras. So those kind of applications are all running via the PON architecture. We also have some of the direct fiber connections. I mentioned the Crestron NVX, but we also have the outdoor Wi-Fi access points. Works the same way as that NVX, where we do have a dedicated fiber which would connect into an SFP cage in that outdoor wireless access point. So with that, I will progress to the next slide. So they say sometimes pictures are worth 1,000 words, so I decided to throw in a couple of pictures to walk you through what our building looks like. I'll also, you have an open invitation for everybody on the call if you'd like to come by and do a tour. We do frequent tours, so we're excited to have clients come through, so feel free to contact myself or Neil or Blaine to get that scheduled. But what I'm going to talk to first is the top left-hand side of this slide. That's our main distribution frame, or MDF. So this is the single telecom closet, which is the distribution for the entire building. And so we have a total of 7 racks. That center rack is where all those network electronics are housed that I discussed in that previous slide. So the top of rack switch is in the top of that rack. Obviously, we have the 8 software-defined data planes that are served as aggregation for our point-to-point connections for the AV, for the Wi-Fi, for the cellular. And then we also have those 2 optical line terminals. So all of that is housed in that center rack. And then as you go to either left or right, the adjoining racks are all representing the distribution for a floor. So it's a 6-story building. So we have the lower level, level 1, level 2, level 3, level 4, and level 5. On those racks where we have the fiber distribution, what we're doing is we're taking a fiber patch cable, which is either coming from a software-defined data plane for a point-to-point configuration, or it's coming from that optical line terminal, which is hitting that optical splitter, allowing us to serve many ONTs for great density. We're also injecting power as well. So we do need to power these software-defined access nodes throughout the building as well. And so all of the powering for this 6-story building is also originating in the same closet as well. We do that through the PSU6 product that was mentioned previously. And so we're patching a 100-watt circuit into our CCH patch panel. We also have the fiber patching in, and then out the back of that housing is our composite cable. And so in this building, we have approximately 500 composite cables, which are serving the 6 floors. If we had done this in a traditional manner, we would have obviously had a closet on each floor, and we would have had about 400, 500 cables leave each closet to be able to get the network drops that we ended up deploying in this site. Moving to the bottom left-hand side, this is a picture of the actual installation itself. And so this is an open air office. It's an open ceiling office as well. So you can see everything. Our idea was we wanted the hidden to be seen in this building, and I really do think it made for quite a beautiful installation and a beautiful result. Here you can see we're using a reel in a box product. So it looks very much like pulling a traditional category cable. So because we are pulling a lot of fiber in the horizontal, This reel-in-the-box products that Corning offers allows us to pull many cables simultaneously, and you're seeing that on the bottom left. If I go over to the right to see a picture of the cable tray. So in this building, when the architect was originally talking to us on this building, it was going to be a traditional network, and they had planned for 24-inch cable trays in order to handle all the category cable that we would have required for all of our network connectivity. We ended up reducing that to a 12-inch cable tray, which is the picture that you see there. And as you can see, we're only taking up just a small portion of that cable tray. So we could have easily gone to a 6-inch cable tray or even maybe just J-hooks throughout the building. So the amount of cable that we reduced in this architecture is quite dramatic. Flowing over to the right, I wanted to point out that this environment is both indoors and outdoors. So we do have quite a few cameras as well that are in the outside in the parking area. And so this is an example of that same software-defined access node. So we have a composite cable, which is centrally located and going into the building. And that's serving our software-defined access node, or ONT, at the base of these poles. And then that allows us to serve the IP devices. And in the case of this picture, it's one of our cameras. So also really nice way to get a lot of distance covered. So a lot of the runs in our parking lot are well over 1,000 feet, and some of them approach that 2,000 foot mark. Center top, that's what we would consider one of our zone locations. And so for us in this building, a zone is really just an ONT location, or a software-defined access node location. And so you can see here, this is our 8-port model. So it's an example. I believe this one is sitting on top of one of our large conference rooms. And so we've got a single composite cable, which is going down to that MDF. I'm providing both the fiber connectivity, but also the power to this ONT. And from there, we have up to 8 Cat6 jumpers that are leaving there that are serving things. I think in this case, it's serving touch panels, scheduling panels for one of the larger conference rooms, as well as conference phones. Bottom right, that is an example of the pervasive Wi-Fi and cellular that we have in the building. And so in our case, we do have a dense deployment of Wi-Fi access points. Again, all of those are deployed via our software-defined access nodes. So you can see that first picture there is a Cisco AP, patching back up to our 8293 ONT. And then on the far right there, you see an example of our SpiderCloud radio nodes. And so those radio nodes look very much like a wireless access point, but instead of providing 2.4 or 5 gigahertz signal, this is licensed frequency. So we do have these deployed for both AT&T and Verizon, and both those radio nodes are going back to a single ONT in most locations. And finally, on the top right, this is an example of one of the AVs. I think this is an open huddle space that you're seeing in this picture. So again, we have a composite cable coming down, and we're patching a fiber directly into that Crestron NVX, which is providing us the 4K video distribution that we're enjoying throughout the building. If you could progress the slide, please. And finally, this is the end result. So this was we had a third party do both a traditional design as well as a fiber deep design. We wanted to know ourselves what kind of savings we would achieve. This is the final takeaway. And so again, the building is approximately 175,000 square feet. In our case, we leveraged that one MDF closet. That was the distribution point for all of the cables leaving throughout the building. Obviously, in a traditional design, you would also have an MDF closet. The big difference here is in the IDF. So we leveraged one IDF. Our IDF was not for cable distribution. It was just for that redundancy piece. So on the third floor of our building, we do have a secondary closet that we leverage. That's where the secondary router sits. That's also where the secondary top of rack switch sits. The rest of the closets were not needed. In a traditional design, because we had to limit ourselves to that 300-foot rule or 100-meter rule, we would have had to have a closet on every floor, which totaled 6. Total drops. So in our deployment, there are no category cable drops that are leaving a closet. In a traditional design, you can see we'd have quite a lot, over 2,000. That would be to hit all those network ports. But then often case in a traditional design, you're having to pull additional category cables just in case. So as an example for Wi-Fi today, when you do see a traditional deployment, in most cases you see people pulling 2 category cables as an example. Fiber drops, I mentioned we have approximately 500 drops that are all leaving that single closet. In the traditional case, the partner that put this together for us was also going to still be using a fiber connection for those Crestron NVXs. But for us, we had those 509 cables, which are serving everything, the NVXs as well as the software-defined access nodes. Next, linear feet of cable. So this was a big one. So we reduced the cabling footprint in the building quite drastically by allowing us to have a single composite cable, like that picture that I showed you in the previous slide. We have a lot of locations where we have one cable that leaves that MDF, hits an ONT, and then just short jumpers, category cable jumpers going to those end devices. So that allowed us to take a lot of cable out of the cable tray, a lot of cable out of the closets, which is really nice. Cable trays, we went from a 24-inch cable tray to a 12-inch cable tray, and as I showed you in that picture, we could have easily gone to a 6-inch cable tray or even just J-hooks. Total switch ports, so we actually have more switch ports in our design than we would have had in a traditional design. The reason being is a lot of our ONTs have spare capacity on them. This is great and really allows for a lot of future proofing. So if I do want to add an AP, I have a software-defined access node sitting close by. If I want to add a camera, I don't ever have to pull new cable. I have plenty of spare ports sitting out at the edge of my network, which is really nice. And then final, the total savings, which is both material and labor in this case. So we didn't give ourselves any extra dollars for eliminating closets and things of that nature, but it worked out to just under 30%, so 29%. So again, this is our building. We're quite proud of it. Very happy to host tours or to answer questions that you might have. And so with that, I think I will progress to the last slide, and I'll pass it back to Rich to see if we have any Q&A from the audience.
Yeah, we do. Thank you, Jason. That was very comprehensive. I appreciate that. There was a spot in your discussion where you cut off for about 4 or 5 seconds. I'm not sure you were aware of that. But there was a question that was passed along about the cost of the cable again. And it was about during that part that you cut out for about 5 seconds. So could you just reiterate about the fiber cost? And Peter, maybe you can go back to that slide about the the cost per foot and your discussion, Jason.
Me?
Can you
Okay,
go back
sure.
to the let's see if Peter can go back to that slide. And so someone asked a question, if you could reiterate the cost per foot.
Oh, this is Neil. Was it during the part where I was discussing if we were going to run 4 Cat6 cables versus running a single composite fiber out to a work area outlet?
Yeah, it was you.
I may have missed
discussion.
Yeah, let me go back to that and make sure I didn't misspeak. So what I was explaining in my example is if we were to run 4 ports of category 6A cable, it's 36 cents per linear foot. So what I was saying is we multiply that by 4 to get your 4 data connections. That would cost $1.44 per linear foot if we were running CAD 6A to get four connections at a workstation outlet. Compared to running, the composite fiber, maybe I misspoke there. It's about 54 cents a square linear foot. And that allows up to, again, 8 data connections if we're using a software-defined access node with a total of, 8 ports on there. So the access nodes, as I mentioned, they come 1 port, 3 port, 4 port, and 8 port. So in regards to, using the composite cable, scale and reach is really, and as Jason just said in the case study here, they ran this composite fiber from a single, MDF point all the way out to, the edge devices. So there were no category 6A cables, as he said, run from any of his IDFs or MDFs because, they didn't actually have any IDFs in this design. It was all done from a central. And I think in the photos, they had the main MDF where everything was served out of. That was the glass bowl room. I don't know, Jason, if there's any more you want to add on to that.
Jason, there was a question
good.
for you. I don't know if there's anything more to add to that, but there was a question. If you're going to answer while you're doing that, someone asked the question, how many employees and visitors are served by the Corning network on your site? So go ahead and answer.
Sure. So the building itself has a capacity to hold approximately 700 people. And so we have this building, and we actually also have land next door that would allow us to build an additional building if we ever need to do that in the next several years. But the seating capacity in our building is approximately 700 employees.
Got it. And was there a question Neil passed off to you, Jason, about this? Neil, did you hand it to Jason to answer?
Yeah, I didn't know if he had anything addition about, you know, their costing model in relation to the building. You know, we had a 29% savings, but you know that took into account not just I mean, Jason, that 29% saving was the replacement for running, you know, basically all of the Cat 6, you know, 8 cabling, which, you know, replacing that with the fiber, the Actify fiber, correct?
That's right. So the 29% savings, what that calculation is, it's the cost of material. So that's the network electronics. So in the case of a traditional design, that would be PoE switches in each closet. That takes into consideration the labor to pull that cable, both in our design where it was we're pulling fiber cable compared to pulling a category cable. Obviously, in the traditional design, we're having to pull a lot more cable, so that's it does add to the labor cost as well. So it is material and labor. What it did not include was we didn't give ourselves any $100 a square foot for eliminating an IDF closet or anything of that nature. So this is just strictly labor and material.
Got it. So a couple more questions that I'd like to tag team onto what you just said. You talked about having PoE switches. Are you exploring the ability to go and use sort of a digital electricity scheme for the entire building using PoE switches and being able to get, you know, power downline on your cables?
Sure. So our composite cables are 300 volt rated, so we do support digital electricity and deployment. In the case of our building, we served everything from a single closet, so there was not a need to have to leverage digital electricity. So we basically what we're powering at the edge of those devices were our ONTs, and so we didn't have a need to deliver more than 100 watts, which is your typical low voltage cabling. But having said that, other deployments that we've done where we have a reason to provide 500 watts or 300 watts or whatever that happens to be. Our composite cable certainly does support digital electricity, and we have done quite a few of those deployments as well.
Gotcha. Okay. And just to piggyback on that, does Corning provide sort of customized cables for customers who want to do things differently, more of one type of cable, less of another, in both sort of size and type of cable included? Is there a customization factor in what you're doing in fiber?
Sure. So we do have a very large portfolio of cables. As you might can imagine, with Corning, if it's fiber related, typically we have lots of different options, and that's also true in the case of composite cable. So in our composite cables, we offer anything from a single fiber up to 24 fibers. From the copper conductor size, anywhere from 2 conductors to 12 conductors. We offer that in 18 gauge and 20 gauge, 14 gauge, 16 gauge, all the way to 12 gauge on the large size. We offer that as indoor plenum. We also offer it as indoor-outdoor cable. So the picture that I showed you with the outdoor ONT for the security camera, that was using an indoor-outdoor composite cable. We offer it as armored, unarmored. So we have quite a large list. So if whoever asked that question is interested, feel free to send a note to somebody here, and I continue the full family spec sheet that'll give you all the different varieties. But we do have quite a large portfolio for our composite cabling.
Gotcha. And so, I mean, I open this up to anyone who would like to answer, either Neil or Blaine, also, besides you, just Jason. I saw the name Gensler on one of the slides, and I know they're a design house, but are they capable, are the typical building design houses capable of doing a design like this for one of our readers or listeners here today, or is this something that we need to bring in companies that are specialists in this? So I know Gensler is a huge company, but are they oriented towards this, or is this something that begs for a CTS to come in and do the design work on top of one of those companies?
Hey, Rich, this is Blaine. Let me field that. So I've got a couple of scenarios, had a couple meetings in Southern California, and I met with actually a design firm that said that they really don't do much from a fiber to the edge or convergence, because they said, and a simple answer was that they said our guy that's working on the design standards for Division 25 are sitting next to the guy working on Division 27, and they never talk. He said they design this separate systems, and so the way that they're set up is not, it doesn't work well with this kind of network. So we've typically seen where we need to go in and help them and assist them, where we go in and do lunch and learns. We help with design standards, design criteria on whether it's just a fiber to the edge standalone, or whether it's converging multiple applications or solutions. But typically somebody like a CTS will need to go in and assist them with their design.
Oh, thank you. That was that's kind of what I was hoping you'd say. So last question, and this is a little more complex. On one of the slides I saw there was an SD-LAN comment on there. So how does the SD-LAN and SD-WAN technology fit with this and what you're doing here in this scenario? Is the SD-WAN and SD-LAN with what we've been talking about here on this call?
Actually, Richard,
Jason,
You
you
want me to
wanna
take that one?
take
yeah,
that?
go ahead, Jason.
Yeah.
So you'll see. So in the case of SD-WAN, you'll see that there's quite a few providers of SD-WAN on the market. It's I think an exciting technology, and I think it makes a ton of sense for operators for sure. What we're doing on an SD-LAN side, I would say it is different, and Corning is fairly unique, and then offering the software defined all the way out to the LAN network. So think of SD-WAN as the solution or the connectivity that's coming to your building. SD-LAN is going to be taking that fiber out to the horizontal to those edge devices. So we're doing that on a layer 2 basis. And so really what our focus is with our platform is on the LAN side. Our goal at Corning is we're looking for, we're always looking for applications that could benefit from what fiber can deliver in terms of throughput, in terms of latency, and we really felt the LAN was a rich environment to take that. I've held several roles at Corning. We did the same thing with our wireless side several years back when we were looking at deploying our DAS solutions, and we took fiber deep again. And you can see where 5G is coming now, right? 5G is telling you, hey, it has to be fiber. And so that's where that line is. Think of SD-WAN as being the solution going to my building. SD-LAN is going to be the solution within my building.
That was very helpful. I really appreciate that. And so that's a topic that, we're getting questions about a lot, and I think that was a great answer. So I'm done with questions. I have nothing else from the field, and I think you guys did a terrific job today, because we don't sometimes get deep in enough on some of the topics that we talk about in these webinars. But I think today we actually started at the top, at the surface, and moved deep in. Not to be sort of funny about it, but we went deep and fiber deep in this discussion today on the webinar. So I want to thank everybody for attending. Again, you will get slides, and you will get the article from the magazine, and you will also get a recording, the link to the recording of this in short order. But I would like to thank our participants in this today, Blaine, Neil, and Jason, and thank you all for attending.
Thanks, everybody.
Take care.
Thank you.